Hello, grade 8 math. This is math 8. It's lesson 1.7, applying the Pythagorean theorem. So as we know, the Pythagorean theorem, it's either c or h squared is equal to a squared plus b squared. And which one is 8? H, it's the one that's opposite of the right angle. So we figured out, you know what, if we know the right angle, or it's a right angle, then we know it's a right triangle, we could figure out one of our side lengths. Or if we don't know it's a right triangle, if we have the side lengths, we can figure out whether it is truly a right triangle. That's what we did in the previous 2 lessons. So we know that it is for right triangles only. Now what we're going to do here is just do a little adjustment to this formula right here. This h squared equals a squared plus b squared, so that I'm going to work on rearranging the formulas just so that you are prepared for maybe future math classes in high school. And then we're going to do some maybe real world problems that kind of helps us apply this to the real world. So this is page 49, 4A, and it's got a triangle. So this question looks a lot like the ones we've seen. There's one side that's 21 centimeters, one leg is 20 centimeters. It's a right triangle, so we're trying to find h. Now what we can do is, before we even start and throw in some things, to do a little less calculating, we want to get that variable in this formula, h, by itself. So if we start with our formula up here, this h squared equals a squared plus b squared, h squared equals a squared plus b squared. To get rid of that squared, what do we need to do? We need to square root it. So we're going to square root both sides. So our formula, if we're trying to find just hypotenuse, not hypotenuse squared, just hypotenuse, it is equal to the square root of a squared plus b squared. So a squared is, or a is 21, b is 20. So a squared is 21 times 21. B squared is 20 times 20. 20 times 20 is 400. 21 times 21 is 441. Add those together, it's 841. And then all we need to do is square root that, because we had our square root sign moving down as we go. It's still there. Square root of 841 is 29. 29 times 29 is 841. So it's 29 centimeters squared. So this up here is 29 centimeters, not centimeters squared. I keep saying that. I'm trying to get out of that habit. So you can actually rearrange a formula before you throw in any numbers so that you have the thing you're looking for on that side the whole time, and you don't have to do things to both sides, whatnot, with all these numbers. Why this is convenient, why in high school you're going to be expected to do this kind of thing, is because sometimes you're not dealing with easy numbers that you can write like 2.1. Sometimes you're dealing with, 15 decimal places. If you had to rewrite that number over and over and over as you were doing a question, it would take a whole lot longer. So the reason why we use variables and we rearrange it first is so that you're just having to write h, not 12 digits. 5a looks similar to one we've seen, but we're going to rearrange this formula here. So one side's 18, one side's 30, one's a, and we look at the right angle. The two that add together are the ones that are the segments that make that right angle. They meet at that right angle, so this has to be one of the legs. So hypotenuse squared is equal to a squared plus b squared. We want to get this a by itself, which means we need to get a squared by itself, so we're going to subtract b squared from both sides. These cancel out. A b squared subtract a b squared would be 0. A squared would be still here on this side. I'm just going to erase something. We're left with a squared over here, and we had h squared subtract b squared, so it's h squared subtract b squared. But we want to get a by itself because we're trying to find a this side here. So what do we need to do? We need to square root this side, because a square root of a square is that thing inside. So this side will equal a. But if we square root this side, we also have to square root the other side, the whole thing. So we figured out here that the square root of h squared subtract b squared is equal to a. However, we like our formulas so that the variable that's by itself that we're trying to figure out is on the left side. So all we're doing here is we cross it over to the other side. So a is equal to the square root of h squared subtract b squared. The square root of h squared subtract b squared. You see how these are actually the same, it's just we flipped the sides. So now that we have that, we can just put in these numbers here. Where h is, we're going to put what h is. H is 30 centimeters. Where b is, we're going to put in 18 centimeters. And then we're just going to calculate it out. 30 times 30 is 900. 18 times 18 is 324. 900 subtract 324 is 576. And there's a square root sign over this the whole time, because there's a square root sign here, there's one here, there's one here, there's one here, until you finally square root that 576 by realizing that 24 times 24 is 576. So that's when it gets rid of the square root sign, and we're left with a is 24 centimeters. I'm going to let you know that also, what if you're not trying to find a, you're trying to find b? That you can actually use this formula that we could derive the same way, except subtracting a instead of b from both sides up here. And you would end up with essentially the same formula for your other leg, except instead of a, it's b, instead of b, it's a. So this formula, this formula, this formula can be used because they're technically just the same formula as this one up here, just a little change to it, moving things around. Here's an example similar to the questions in question A that you'll be doing on your assignment. It drew a line here, right? And it said, find the length of h. You know, earlier in this unit, we did this long process. We drew a square off of it, and we drew some triangles and a square in the middle, or maybe some triangles on the outside, and we did a bunch of subtraction. It took a long time. Why did we do that? Part of it was to emphasize the Pythagorean theorem and how awesome it really is. If we look here, we could turn this line into a triangle, or a part of a triangle, by following our grid line down, and following our grid line over, and making a triangle. And we can say that this is a right angle because we know our grids, these grids on this grid paper, it's always that right angle. So that's a right angle, and we can figure out that this side is 3 and this side is 6. In the real world, this could be, there's two people standing here, right? We've got two people standing here at these points. They started here and they went searching for berries in the forest, and one went straight north 3 units and one went 6 units to the east. And they want to know how far away they are from each other. The hypotenuse right here. That's just a real world problem. I don't know why they'd want to know that, but maybe it's important sometime. But with this model here that we've drawn, we can actually figure out what that distance is. How? By using Pythagoras' theorem, or the Pythagorean theorem. We know that h squared is equal to a squared plus b squared. So h squared is equal to, a is 3 units squared, plus b squared, which is 6 units squared. Remember, this is the big thing that I've seen a mistake on a few times. People see a, and they say that's 3 units, and it's a squared, so that's squared. That is not correct. That is not correct. Why? Because only the unit was squared here. This here, when it says squared, we're saying square the whole thing, all of 3 units. We need to square it. Not just the unit, we need to square the 3, which 3 times 3 is what? It's 9 units. So this is not what it means when we square a. It's this. It's 3 times 3. Okay? So 3 times 3 is 9 units squared. 6 times 6 is 36 units squared. Add those together. 9 plus 36 is 45. So h squared is 45 units squared. Then we square root both sides because we want to find that length. We're not just trying to find the square that would be made from it. Square root of a square is h, square root of 45 units. Now, because this wasn't a perfect square, this is the number that we write for answer, unless they say, tell us the answer to 1 decimal place. And in this case, it would be 6.7. Remember, the perfect square that's greater than 45 is 49, which is 7 squared, right? And the one that's less is 36, which is 6 squared, so it has to be between 6 and 7. So estimating, we'd expect it to be around 6.7 anyways, because 45 is a little closer to 49. Question 10 on your assignment, I'm just going to give you a little tip. They said there's a dock, and from the dock, one of the boats goes south 35 meters, and one of them goes east 84 meters. How far are they apart? This would be a model that would help you if you're stumped by that question. And you might be able to notice that this is a right angle in this corner if it's straight east and straight south. And that is the unit. So we've determined Pythagoras' theorem. We've learned square roots and squaring of numbers. And that's what we've done this unit.